Today we shall discuss about potential energy acquired by a body. So by the definition of potential energy, it is the energy possessed by virtue of state of rest or deformed state. The deformed state represents the present configuration of the body. We are well known about the fact that a body at rest is possessing some amount of potential energy. The state of rest is not absolute rest. It might be a state of rest where the body is in a deformed state, or that is the state which defines the configuration of the body itself. Which means the body is under the action of some force due to which its shape or structure might have changed temporarily. After that force has been withdrawn, the body will definitely acquire its previous state. So the energy, not only in the state of rest but also in the state of deformation, will be defined as potential energy. There are various forms of potential energy. Say for example, elastic potential energy and gravitational potential energy. The elastic potential energy is due to a property which is called as elasticity of the body, and thereby you can say that the elastic potential energy is the potential energy that the body will possess in its deformed state. Now the deformation is due to a force acting on the body, and that force has somehow changed the present configuration of the body, which means that the body has temporarily changed its shape or structure, but after the deforming force has been withdrawn, the body will again regain its original status or original configuration. There are varieties of example. A wound up wax spring is in a deformed state, and so it has some amount of elastic potential energy. A stretched rubber cord, a stretched bow are examples where the material is in a deformed state due to some force acting on it. A compressed or elongated spring is also in a deformed state, and so it will also possess some elastic potential energy. Now this situation is due to the property of elasticity, and elasticity you can define as the property by which a body will regain back its original state or original configuration after the deforming forces have been withdrawn. Remember that there is no permanent deformation in the body. If there is a permanent deformation in the body, then that is not under the discussion of elastic potential energy. The deformation is temporary, the force is acting on the body due to which its shape has changed or its structure has changed, but when the deforming force has been withdrawn, the body is capable of regaining its original configuration or original state. So that's why we say that potential energy in the deformed state is elastic potential energy. And definitely that potential energy acquired by the body is due to the work done in deforming the body. The force that is acting on the body and is capable of providing a deformation will definitely do some work. The force acting on the body is doing some work, and the work done in deforming the body is equal to the elastic potential energy stored in the body. We don't have any mathematical equation that represents potential energy in deformed state at present, but that can be defined elaborately in the next class. So now we shall focus on what is gravitational potential energy. For this we have a mathematical equation that we will frequently use in numericals. So gravitational potential energy is the energy possessed when the body is kept at some height above the ground. Ground represents the surface of the earth. Now this potential energy that the body will acquire when it achieves a specific height is equal to the work done in lifting the body to that height, and the work is done against the force of gravity. The work is definitely done against the force of gravity. There are many examples where we can realize the gravitational potential energy. Any object kept at some height above the surface is possessing some amount of potential energy. For example, water at some height above the surface in a dam has gravitational potential energy stored in it. So for the mathematical expression, we assume that a body of mass m is lifted to some height above the Earth's surface. That height is, say, h. Then we have to do some work against the force of gravity. So force into displacement, here displacement is h and the force of gravity is mg. So mg into h will become the work done to lift that particular object above the Earth's surface to some height h. So this work will be stored as gravitational potential energy, which we shall denote by U, and therefore U is mgh. Now in this situation we have assumed that the body, when it is on the Earth's surface, its potential energy is 0. Actually, whenever an object is lifted to some height h above the Earth's surface, it gains some amount of potential energy. Because we always assume that on the Earth's surface, the potential energy of the system that comprises of the Earth and the body is 0. Remember that the potential energy on the Earth's surface is not the potential energy of the body itself, it is the potential energy of the system, which means it is the system comprising of the Earth and the body itself. Togetherly, the system has a potential energy 0 at the Earth's surface. And so whenever we lift the object at some height above the Earth's surface, it will gain some amount of potential energy. As we have already obtained a formula for the gravitational potential energy U, that is mgh. So, if a body of mass m is taken up from height h1 to height h2 above the ground. So suppose the body was initially at the point A at some height h1 above the ground, and the body has been taken to the height h2 and its new position is position B. Then it has gained some amount of potential energy, and the gain in potential energy will be the final potential energy minus the initial potential energy. The final potential energy is mgh2 because the position is B, so height h2 is above the ground, so mgh2 minus initial potential energy, which will be mgh1 because the previous position was the position A, which was at height h1 above the ground, and so the gain in potential energy will be mgh2 minus h1. Similarly, if the body of mass m, it falls down from some height h1 to some height h2. As per this diagram, the body was initially at the point A at height h1 above the ground, and it has went down to some point B at height h2 above the ground. Then it has lost some amount of potential energy in descending that specific height. So its loss in potential energy will be initial potential energy minus final potential energy, which will be mgh1 minus mgh2, which becomes mg into h1 minus h2. In this case, the body has gained some amount of potential energy. In this case, the body has lost some amount of potential energy.